Say, welcome to Augmented Matrix Solutions. Our objective is to solve a system of linear equations in three variables using the augmented matrix method. The other term for augmented matrix is Gaussian elimination method, formed by writing the constants on the right-hand side of the equations as a column and attaching this column to the matrix of coefficients. Suppose we have 3x minus 2y plus z is equal to 2, x plus 4y is equal to 9, 2x plus z is equal to 5. You have to make it to the form 3 negative 2 1 2 1 4 0 9 2 0 1 5. You have to replace, if the variable is not written, you have to replace it by 0. Okay, so in representation, we have a sub 11 to a sub 13, a sub 21 to a sub 23, a sub 31 to a sub 33 to the form 1 0 0 0 1 0 0 0 1, or if you still remember, that is identity matrix 3 by 3. X is equal to R, Y is equal to S, and Z is equal to T. Let's proceed to our first example, but this time it just involves two variables. Okay, so since it's just a 2 by 2 matrix, we have to make it into 1 0 0 1. The representation of it is 4 5 negative 2 negative 1. Okay, so our first target is you have to make it as number 1. So this first column first. Okay, so just to remind you that if the operations involved across is just multiplication and division, and if you are dealing with up and down, that is addition and subtraction. Okay, so in making it positive 1, you have to multiply across to 1/4. Okay, so 4 times 1/4 is 1, and 5 times 1/4 is 5 over 4, and 7 times 1/4 is 7 over 4. Then just copy your second row. Next is to make this one into 0. So how are you going to make negative 2 to 0? So just multiply your row 1 into positive 2, then add row 2. So it can be represented by 2 times row 1 plus row 2. So just rewrite 1, 5 over 4, 7 over 4, then 1. Let's proceed to this one. 2 times row 1, 2 plus negative 2 is 0. 2 times 5 over 4 is plus negative 1 will become 3 halves. And then on the last one, it should be 21 over 2. Next is, we have to make your second column 1. That is your next target. Make it 1. So again, we have to, if you're gonna make one element in each row, you have to deal with 1 first. Okay, make it 1. So you have to think of a number wherein if you will multiply in each element in a row, this second row or second element will give you 1. Yes, we have to multiply it by 2/3. So 0 times 2/3 is 0. So 3 halves times 2/3 is 1. And then 2/3 times 21 over 2 is, we will have 7. Okay, so next is, since we have already 1 1 0, you have to make 5 over 4 to 0. How are you going to make it 0? So we will make it 5 over 4, negative 5 over 4. So negative 5 over 4 times row 2 plus row 1. Okay, negative 5 over 4 times 0 plus 1 is 1. Negative 5 over 4 times 1 plus 5 over 4 is 0. 1 0. And negative 5 over 4 times 7 plus 7 over 4 is negative 7. Okay? So this one, we will have your x as negative 7, y as 7. Therefore, we have this solution. Okay. So next is 3 by 3 matrix. So first, since it is already declared or is expressed as 1, we have to make 2 as 0. In order for us to make that 0, we have to multiply your first row into negative 2. Negative 2r1 plus r2. So negative 2 times 1 is negative 2 plus 2 is 0. Okay, so negative 2, 0. Next is negative 2 times 3 is negative 6 plus negative 3 is negative 9. Negative 2 times 8 is negative 16 plus 1 is negative 15. Negative 22 times 2 is negative 44 plus 5 is negative 39. Okay, this one. Just copy the third row. Next is, since we already have 1, 0, make this third number, third element in a row, third row, make it 0. So this time, we have to multiply your first row into negative 3 plus row 3. Negative 3 times 1 is negative 3 plus 3 is 0. Then negative 3 times 3 is negative 9 plus negative 1 is negative 10. Negative 3 times 8 is negative 24 plus 2 is negative 22. Then negative 3 times 22 is negative 66 plus 12 is negative 54. So this is your third row. That's it. Next is, you have to make your second column, this one, into 1. So again, if you want to make a certain element in a row as number 1, you have to multiply across to its reciprocal. So the reciprocal of it is negative 1 over 9. So negative 1 over 9 times 0 is 0. Negative 9 times negative 1 over 9 is positive 1. And then negative 15 times negative 1 over 9 is negative positive 15 over 9 or 5 over 3. And negative 39 times 1 over 9 is negative 39 over 9 or negative 3 over 13 over 3. Or this one. Okay, 13 over 3. Next is, make it as 0. So, our hint now is this one. So, you have to multiply the second row into positive 10 r plus last row. Okay, 10 times 0 is 0 plus 1 is 0. 10 times 1 is 10 plus negative 10 is plus negative. This one remind you that it's just row 3. So 10 times 1 is 10 minus 10 is 0. And then 10 times 5 over 3 is 50 over 3. Or simply this row. It's next is make 3 0. How? So we have to multiply the second row into negative 3 r2 plus r1. Okay. So negative 3 times 0 is negative, or 0 plus 1 is still 1. Negative 3 times 1 is negative 3 plus 3 is 0. Or this one. Next is third column. So again, in each column, you have to first solve for 1. Get its coefficient, reciprocal. So negative 3 over 16. Multiply across, you'll have this. So next in line, I can show you how to multiply each, but you can perform it using your calculator. But I just want to remind you that please be careful in solving such, because one mistake will make you go back from scratch. Okay, so next is you have to make this 0. So again, here is your hint. That is the very reason why you need to solve for the value of 1 first. So what should be added to 5, 3 to make it 0? So it's gonna be negative 5 over 3. So multiply your row 3 to negative 5 over 3 plus row 2. That's why negative 5 over 3 plus 0 times 0 plus 0 is still 0. We're dealing with the second row. So negative 5 over 3 still 1. Negative 5 over 3 times 1 is negative 5 over 3 plus 5 over 3. Then that will become 0. Then just multiply negative 5 over 3 times 2 plus this one. You'll have this. And last one, you have to make your 3 0. In making that 0, you have to multiply your third row to negative 3 plus R1. Negative 3 times this one still will give you the first 0, 1. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 2 is negative 6 plus 9 is this one is 3. And then have 3, 1, 2 as our solutions. So these are the solutions. The last augmented matrix corresponds to the system of equations x is equal to 3, y is equal to 1, and z is equal to 2. Therefore, the solution is the ordered triple 3, 1, 2. You can check your answer by using substitution method or substituting for x, y, and z in the original equations. To deepen your knowledge on augmented matrix method, you could have this practice. Thank you very much and God bless you all!